Good afternoon, all. With a very much less strength, let me start the today's session. I'll just recall what all we covered in the previous session. We have started with the problems on module 1. Uh, in module 1, the theory concepts were Coulomb's law of force, then electric field intensity, and the charge distributions. Along with that, some introductory part of electric flux. So based on these concepts, let's try to solve few problems. We have already started with the Coulomb's law. The Coulomb's law of force. We started with this first problem. Already we have discussed about this, how to find the force on both the charges, F1 and F2 both. And a similar kind of problem was given as a work to you. I think somebody had messaged me through the WhatsApp the solution. I did not see it. Please, whoever had sent me, please send it one more time. I want to see the answer. This is the second problem, given homework. Let me solve one more problem based on this. It's again a similar. This is your prescribed textbook problem. Third problem, a charge QA of minus 20 microcoulombs is located at point A. Some point is there. Imagine there is a charge at some point A. And there's one more charge QB, which is 50 microcoulomb. It is at point B. Okay, in a room, assume you are in a room, in a classroom, two charges are there of two different magnitudes, and at two different points in the space they are located. Now, if the distance between them, whatever we measure here, it is given that it is in meters. So we need to find certain parameters here. Let's see one by one. The very first thing is capital R suffix AB. Capital R indicates what? The distance, okay, the position, the distance between the charges. If you take the magnitude, it will become what? The magnitude will be in some meters. And if you see the position vector, it will be in three different directions. So let's see one by one. First, for any given problem, you should start solving it by collecting the given data. So I have written here the given two charges are given to you and 2 points where they are located, it is given to you. Now, can you imagine this? Can you try to represent this situation in the form of a diagram? Try to put this in the form of a diagram. I have done that. There is one point A here, one more point B. At point A, charge QA is there. At point B, charge QB is located. This is no doubt on the paper I have shown you, but actually they are in space. Okay, in a classroom, two charges are located at A and B with some spacing. Now, if I consider O as the origin point, this will represent the distance of origin and first charge QA. This line represents the distance between the origin and the second charge QB. So this is the pictorial representation of the given problem. So I have presented this in the form of a diagram. Now, according to the given question, we need to find this capital RAB. So let's try to find the position vector. Before that, what I have done, I have found out the magnitude. Because to get any vector, unit vector or any vector, the vector divided by magnitude will give you the position vector. So first, the distance between these two, how to find? You have coordinates given to you. 2 points are given to you. I have marked them as x1, y1, z1, x2, y2, z2. So if two positions, the 2 points are there in the space coordinate system, 2 points are mentioned to you. Use the distance formula, find the distance between them and its magnitude you can calculate. It is the square root of these two x values subtraction. See, minus 6 minus 5 whole square, 4 minus 8, second y coordinate, 4 minus 8 whole square, third z coordinate, 7 minus 2 whole square, 7 minus of minus 2, 7 plus 2 whole square. So square root of this will give you the magnitude. I have calculated it. I think I missed it somewhere. Yeah, it is 11. Okay, 11 square plus 4 square plus 9 square. You will get it around 14.76. This is the magnitude, the distance between the two charges. Now to find this RAB, okay, position vector, any vector, how will you calculate? The vector in three different directions, x, y and z, divided by the magnitude, that you will do. So according to this triangle, you can see, try to apply the addition, vector addition. If this is the point origin, the direction is in this way, the second direction is in this way. Now to decide the third direction, I will make use of the given data. If you see, it is minus 20. QA is negative. So if any negative charge exists, according to the conventions, towards the negative charge, the lines, the field lines, they converge. Okay. So if it is negative, the direction will be like this. Okay. And I think I have missed something here. I have used both suffix QA only. Okay, let me confirm it. QA is minus 20, QB is 50. Okay, so please make this QB. Okay, QB given is 50 microcoulombs. So it is a positive charge. So according to that, using the convention, the field lines from the positive charge, they diverge, they go out. So according to the conventions, if we use conventions, the direction is like this. They diverge from B and they converge at A. So that's why let me take the direction in this way. And A direction is like this, B direction is like this. So this is the directions. Now how to find the addition? Try to identify two continuous arrow marks. Okay, if I take this arrow mark 0 to A, there is no continuity from there. 0 to A and A to B I cannot take because it is not continued. Now let me check with this. 0 to B, yes, and from B to A, yes, there is a continuity. Take in this anti-clockwise direction. So according to that, if I take R2 plus RAB will give you capital small r1. Okay, so from this equation find RAB. What is RAB? RAB is R1 minus R2. So what is R1? R1 is considering these points, R2 is considering these points. So the subtraction will be x1 minus x2. Okay, it is not x2 minus x1, it should be 1 minus 2, because just now I have shown you here the direction should be taken in anti-clockwise. R2 plus RAB equals to R1. So RAB will be R1 minus R2. So accordingly, I have taken here, okay, I have done something, some mistake I have done, I guess. According to that, R1 minus R2, I should be taking like this, I guess. Okay, it is wrong. What you do, you take the positions like this direction plus this direction. If I take R2 plus RAB, let me write it clearly, equals to R1. So what is RAB equals to? RAB equals to R1 minus R2. If I take this R1 minus R2, the points will be minus 6 minus 5. Okay, I have taken it reverse, 5 minus of mine. So this is wrong. So take it in reverse, the way I have taken it here. Minus 6 minus 5 AX plus 4 minus 8 AY plus 7 minus of minus 2 AZ. So all three directions. Please don't take this because I have taken it in reverse. I have done R2 minus R1. You should not do that. You should do R1 minus R2. What changes you will expect if I do that? The signs will get changed. This will be negative, this will be negative, this will become positive. The signs will get changed. So please make sure you're subtracting correct values. Subtract R1 minus R2. Don't do R2 minus R1. I have done that. Now, once what all we have done, we got this position vector, we got this magnitude. We need to now find the force exerted on charge QA because of the existence of charge QB. So obviously when two charges are placed, because of one charge, the other will it will experience a kind of force, maybe attractive or repulsive depending on the sign. So we have QA will experience a charge because of charge QB. Similarly, QB will experience a force due to the charge QA. The question is only one, okay, not both. Find the force exerted on QA due to the charge QB. This much we need to find, only one part. So let's see. Make sure, okay, these signs should be changed. Okay. The force exerted on the charge QA due to the charge QB, it is given by, I have taken this suffix F suffix capital A. Okay, notation 1 by 4 pi epsilon naught QA QB divided by the magnitude of the position vector square into the AR. Now, unit vector AR I have calculated. So here again I have made a blunder. What I did, I have taken the wrong directions. See here, all these signs should be changed. Plus. So, but I have taken this as it is. So please, the complete problem will be, the signs will get changed. This will be minus, minus and plus. So whatever unit vector is there, unit vector is given by, already we have calculated the position vector and the magnitude. So take the ratio of this divided by this. You will get the unit vector. But however, the answer here will be somewhat different. Negative, negative, positive. So the force will be 1 by 4 pi epsilon naught. Epsilon naught I have taken 1 by 36 pi, but you take 8.854 into 10 to the power of minus 12. The epsilon naught value is 1 by 8.854 into 10 to the power of minus 12. You take that and calculate. I have taken this value just to cancel this pi. Okay. QA into QB, charge QA into QB divided by RAB square, the magnitude square. What is the magnitude we got? 14.76. So 14.76 square into AR. I have written AR. Just first what I'll do, I'll just use the calculator, complete all this part, and then I'll go for AR. Simplified way. So step by step I have calculated. You have already got calculators with you. So it's easy for you. Take the numerator, this part. Denominator 4 pi 8.854 into 10 to the power of minus 12, 14.76 square. If you calculate this complete, you will be getting, no doubt you will get a negative sign because of the existence of negative charge. Minus, I have got 41.31. Actually, you will get 10 raised to minus 3. That 10 raised to minus 3, I will count it in milli. In the unit, I will count millinewton as the force. So 41.311, I will get the whole calculation into AR. AR is your unit vector. Unit vector is this much with signs changed. Negative, negative, and the third value positive. If you use that, multiply again, this should be minus, minus, plus. This should be the change. Multiply this into 11 divided by this. You will get minus into minus. The first term you will get it as positive. Plus 30.77. Similarly, multiply 41 into 4 divided by 14.76. You will get minus into minus, plus, I have taken minus common, don't do that, This first term is positive, second term is also positive. That is 11.19 I got. Third time 41.311 multiplied by 9 divided by 14.76. If you do that, you will get 25.18. Minus into plus, you will get a negative sign. First two terms are positive, third term is negative. You will get the force in millinewton, because here I have got 10 raised to minus 3. So I have taken that as it is. Force is expressed in newtons. This is how we calculate the force. Now, if you see the question, find the force exerted on charge. There are two conditions here. There is first is epsilon value, either directly you take it 8.854, or there are two conditions. Second possibility, epsilon value they have given. So for first one, if you see, I have used that only. Epsilon is this, given epsilon. So I'll get this. So second time, similar same kind of calculations, 8.854. Okay, so don't get confused. I told you to use that, but the question is for two different epsilon naught values, you need to calculate the force. Procedure is same, just epsilon naught value, you should change it in both the problems. Okay, this is how we get the force exerted on QA. The other one is not asked. The force exerted on QB is not asked to you. Okay, this is the question from your hate and buck textbook. Okay, directly answer is given to you. There is no solution. Directly you can match the answers. Please make sure I have made a blunder here. Signs should be changed for this, because I have subtracted wrong values. Reverse it should be. Okay. The next problem, it is similar to that, the earlier problem. Hence, this will be a homework for you. I will be putting these homeworks in your Google Classroom. Please, you go through it. Two homeworks are there. I'll just read it out. I'll tell you what to do. A 2 millicoulomb positive charge is located in vacuum at point P1. Say suppose this is your point P1, and some charge Q, that is 2 millicoulomb, it is located here. And 5 microcoulomb negative charge is located at point P2. Say this is your point P2. Here, say I will take this as Q1 and this is as Q2. In the space, again, two charges are kept. Assume, imagine your classroom. Two charges are located at P1 and P2. Points are already given to you. Find the vector force on the negative charge. Negative charge is the second one. So, you have to calculate F2. And why this force exists? This force exists because of the presence of Q1. Okay. If there are two people, if there is a rope in between them, if both people are dragging that rope towards their side, then only the other person, for both people, they will experience certain reluctance. थोड़ा difficulty होती है उनको rope को अपनी तरफ खींचने के लिए, because of the presence of the force which is exerted by the other person. That's why the force F2, it exists because of the presence of the charge Q1. So you need to find F2 here. Again, you make use of a triangle. You take this point origin, take a triangle, decide the direction. Direction, how will you decide? Based on the positive and the negative charge. Decide the direction, use the vector addition. You find out the position vector and find the force F2. Now, what is the second thing? What is the magnitude of the force on the charge at P1? So again, I think second point is also asked. Force F1 you need to calculate. What is the magnitude of the force on the charge at P1? So F1 you need to calculate. There is a continuity in the question actually. They have not directly asked you the vector force. Vector force means you should have Ax, Ay and Az. Just like the previous problem we calculated, we used the unit vector. See here, look at this. We have calculated unit vector. From the unit vector, we have substituted in the formula. Then finally, in three different directions, Ax, Ay, Az, we got the force. So this is called the vector force. But if you see the question here, you need to calculate the magnitude of the force. So till this, you need to repeat. What all procedure we have followed till now to find the force, the same thing till this line, end line we should come, and after that what we need to do to find the magnitude. How will you find the magnitude of this? It's very simple. If there are three different directions given here in Ax, Ay, Az, some units are there: 30.72, 11.16, 25.13. Some magnitudes are there. So how to find the total magnitude? It is square root of the first value square plus second value square plus third value square. So if you do this, you will get some number here. That is the magnitude of the force. If you end only at this, this is called the vector force in three different directions. But if you take square root of these magnitude squares, you will get the magnitude of the force. It is like this, magnitude of the force. So this is the work assignment, homework. Please try this. One more homework. A charge Q2 121 nanocoulomb is located in vacuum at point P2. Suppose I have a charge Q2 at point P2. P2 is given to you. P2 point is given minus 0.03, 0.01, 0.04. So, it is in points. So, calculator should be very much precautionally used. Find the force on this Q2 due to a charge Q1. So there exists one more charge here, Q1, which is 110 microcoulomb at point P1. And P1 points are also given to you, 0.03, 0.08, minus 0.02. Similar, Q1 and Q2 are given to you. Take this a common point origin. Take this. Find the force. You need to find the force located. Find the force on Q2. So you need to calculate F2 here. So F2 need to be calculated. You should find the direction here. How to find the direction? I have shown you based on what kind of charges these Q1 and Q2 are. Based on that, you need to find the direction. So this is also homework to you. Please try to complete this fourth and fifth. Let's go for one more problem. A point charge Q1 is located at point P1 in free space. Again, imagine your classroom. In that, there is one charge Q1 placed somewhere at point P1. And there's one more charge Q2, which is minus 5 microcoulomb. It is at point P2. Two charges are kept. That thing I have shown here. See. Q1 and Q2 are 2 points located like this. You can ask me one thing. If you observe the diagram, I have shown the direction like this. Till now in the 2-3 problems, I have shown you like this, right? Charge Q1 and Q2, some common point O. So why, madam, why you have taken the direction in this way? Okay, that's the very important question that should get into your mind. The reason is, check these two values for both the points. They have given you point P1 and P2, 1, 2, 3 and 1, 2, 10. If you see 1, 2, 1, 2 is common, means the distance of those two charges Q1 and Q2, from x and y direction, it is a constant 1 and 2. It has not changed. The only difference is this 3 to 10. That difference exists. That's why I have put the charges in this way. That is z direction, there is a difference, but not x and y. Suppose that if the points are somewhat like this: 1, 5, 7, 1, say 10, 5. Suppose the question might have been like this, then how would I have used 1 1? X direction is same, z direction is same, the points, only the difference is in y. So I might have used like this. Suppose if x has changed, I might have used in this way. Okay, so why I have used this vertical line to show the difference, the existence of charges q1 and q2 in space, because the only position change is in z direction, vertical. Here in the three-dimensional coordinate system, z I have taken it like this. So just to show that, I have kept it like that. Find the vector force exerted on Q2 by Q1. Again, it is simple. F2 we need to calculate. This is the origin point. Check out, charge Q1 is positive. Q1 is positive. If you see the charges, Q1 and Q2, again, they are of two different positive and negative. Depending on that, you just check out the direction. Find the vector force. It is simple. The way we have calculated in the previous problems, go for calculation of the direction. The distance between uh, R1 and the distance between the two charges Q1 and Q2 you calculate, and then position vector, the subtraction depending on the direction you find out. And once you find the position vector and the distance, take the ratio, you will get the unit vector. And the vector force is given by 1 by 4 pi epsilon naught q1 q2 by the distance square into AR. So if you calculate that, I have got it in this. Okay, this is the magnitude, I got it in AZ direction, because if I do that, yeah, I think I'll get these to 0. 1 minus 1, 2 minus 1, 2 minus 2, 0. Only the third direction, AZ direction, will exist. First point is similar, the way we did in previous problems. There is an important part here in the second sub question. Find the coordinates of some point P3 at which a charge Q3 experiences no force. So we should understand what does this mean. Okay, in order to make you understand this, let me draw it here. It's here. I'll show you. Okay, I hope it is visible to you. The same figure I have drawn it. Position vector is 7 or minus 7. Let me just check. It is minus 7, I guess. Position vector, because 3 minus 10. So minus 7. You check out, because मैं direction में गड़बड़ कर सकती हूँ, but calculations and all you do by yourself. Okay, I have already told you how to take the direction, which one is positive, which one is negative. You check, you take that triangle vector addition, find the direction, and based on that you subtract. Okay, that you do. Don't very much take stress on these points. Try to understand the methodology, that is important. Yeah. Okay, good, Anjum, good question. The same thing I have drawn it here. Check q1 and q2 with 2 points. According to the question, what they have asked, एक point p3 है in the same direction P1 P2 है, सिर्फ Z डायरेक्शन में चेंज है, 1 2 सेम है. सो इन द सेम लाइन मैं और एक पॉइंट P3 लेती हूँ जहां पे x एंड y कोऑर्डिनेट सेम है. ओके, एंड थर्ड आई डोंट नो व्हाट इट इज. सो आई नीड टू फाइंड, ये पॉइंट मुझे फाइंड करना है जहां पर एक चार्ज Q3 रहेगा एंड वो चार्ज कैसा है, इट विल एक्सपीरियंस अ जीरो फोर्स. ओके, क्वेश्चन का मतलब समझो. फाइंड द कोऑर्डिनेट्स ऑफ P3. एक पोजीशन है पॉइंट P3 जहां पर Q3 चार्ज रहेगा एंड ये जो Q3 रहेगा, दिस चार्ज इट एक्सपीरियंसेस नो फोर्स, मतलब जीरो, यहाँ पे फोर्स ही नहीं रहेगा. सो हमको उस पॉइंट का कोऑर्डिनेट फाइंड करना है. कोऑर्डिनेट मींस ये जो मैंने Z3 दिया है, ये वैल्यू को फाइंड आउट करना है. दैट इज द क्वेश्चन. P1 P2 points are there. I have taken one more point in the same line P3, जिसके पॉइंट्स एक्स वाई तो कांस्टेंट हैं, z डायरेक्शन में क्या पॉइंट है वो फाइंड करना है. एंड कंडीशन क्या है, P3 के ऊपर जो हम चार्ज Q3 रखे हैं, दिस चार्ज विल नॉट एक्सपीरियंस एनी फोर्स. इट मींस जो भी फोर्स रहेगा वो नलिफाई हो जाएगा, डायरेक्शन अपोजिट होके और समथिंग कैंसल होके जीरो, नेट फोर्स जीरो रहेगा. दिस इज द कंडीशन. So let me just write it. Let me show you how it is. The same thing I have written here. Let a point charge Q3 be placed at P3 on the line as shown, and I have taken, this is the 7 distance between P1 and P2. आप अभी calculate किए हो यहाँ पे magnitude. The distance is 7. You have already calculated it. ये 7 मैंने यहाँ पे point किया है. That is the magnitude. The distance between P1 and P2, and distance between P2 and P3 we don't know, so I have taken it as x. Okay, now charge Q3 is positive. Okay, assume that. So we have started, we have taken it, Q3 एक positive charge है. It experiences a force. What is Q2? Q2 एक negative charge है. So ये Q3, which kind of force Q3 will experience because of Q2? Because of Q2 it will experience an attractive force Q2 की वजह से, and Q1 की वजह से Q1 has a positive sign. I have assumed Q3 as positive. So positive repulsive force will be existing. That's what I have written here. Q3 positive है and it experiences a force of repulsion due to Q1, because of Q1, because both signs are same, and it experiences a force of attraction due to the charge Q2 because it is negative. So क्या होता है, ये दोनों का मैग्नीट्यूड जब आपको सेम रहेगा, सॉरी, when you calculate both the forces, if they are equal in magnitude and opposite in direction, then only they get cancelled and given condition is satisfied. What is the given condition? It says it experiences a no force. ये no force का मतलब यही है, they are equal in magnitude. जो भी forces experience कर रहे हैं वो, those two forces are equal in magnitude and direction में opposite हैं, इसीलिए nullify हो जाएंगे. They'll cancel and no force on Q3. This is the condition. According to that, what I'll do, F13 is generally for the force on the charge Q3 due to the charge Q1. It is 1 by 4 pi epsilon naught Q1 Q3 by R13 square. एक formula है, general formula. And for the second force, that is the charge, I think I should take this 3-1, right? The force on the charge Q3 due to Q2, it is 1 by 4 pi epsilon naught Q3 Q2 by the distance square. These are the two general formulas, and this is the given condition. Means we have attained this equation because net force zero है. मैग्नीट्यूड में जब इक्वल रहेंगे, डायरेक्शन में अपोजिट रहेंगे, तभी ये इक्वल हो जाएगा एंड नेट फोर्स जीरो रहेगा. सो इक्वेट दीज टू इक्वेशंस. इफ यू इक्वेट देम, these two gets cancelled. Q2 cancel हो जाएगा. Remaining all you write it. Q1 है न्यूमरेटर में, यहाँ पे Q3 है. Check what is R13 and R32.